Hello everyone and welcome to the very first video on this channel. Here we will dive into crazy audio setups, from professional PAs systems and DIY sound systems to wild hi-fi rigs, listening bars and anything that is about the pursuit of the ultimate sound by true enthusiasts. And speaking of enthusiasts, we are starting strong with Restless Audio. Restless Audio is a Berlin-based sound system manufacturer. If you are already into sound system culture, you might have recognized some of their speakers in the intro. Their designs are based on open source blueprints shared online. You will find some of the modern classics of the genre, Paraflex designs, multiple entry horns, and more. But what really makes Restless Audio special is their community. Every month, they host an open listening session in Berlin where anyone can come and experience their systems in a real environment. And once a year, they organized the Weekend of Sound, a two-day gathering for builders, artists and sound lovers from all over Europe. It is a proper celebration of DIY culture and high-quality sound. By the way, if you are the kind of person who loves discovering gear, you probably spend way too much time checking prices on Thomann like I do. Here's a little tip for you. There's a free tool called Audio Deals Alert that lets you track bespoke products on Thomann. You just enter the item you are looking for and it emails you the moment a discounted one becomes available. It is developed in partnership with Thomann, it is totally free and they don't sell your data. They just run on ads and affiliate links. I've already set up mine up for a high-end measurement mic I've been chasing for a while. Thanks to Audio Deals Alert for supporting the channel. You can also support the channel by checking the affiliate links in the description. You will see some really cool gear, really useful for live sound reinforcement and live sound tuning. And if you buy with those links, it will really help the channel. And now let's dive into Restless Audio.
Yeah, hi, I'm Chris.
I'm Manu.
And we're in Motion Lab here. And Motion Lab is a big makerspace, kind of a prototyping place for people that build hardware. And imagine you have a hardware idea, but you don't have the money to afford all the machinery or the space. And then you become a member here and you can use the wood workshop, you can co-use the metal lab, you can use all the machinery and hopefully start a successful business.
Okay, and so your business is one of the success stories here?
Well,
Yes.
I hope it's gonna be. Yeah, so we're building speakers, we started a couple of years ago, and this is where we're currently at. So it came from being a hobby to the main profession now, and we are now kind of exploring how a good speaker, a good product has to be appealing to a bigger audience.
Okay, so sound system enthusiasts will recognize stuff,
Yeah.
because you are using some known design, right?
Yes.
So what is this one?
Yeah, so here you see the Paraflex Elf design. So it's a very powerful subwoofer made up by the HQS community. And the good thing about it is that it's free plans for it. And you can build it yourself. You just download the plans. You can get the right settings. You can even look at measurements to see if it's what you're looking for. And the benefit of this one is that it's very powerful. So it only has a single driver. But for having a single driver, it kind of outputs the same amount of bass like a normal dual driver configuration. In return, it's pretty heavy, so it's always like a workout to move these around, but it's a crowd pleaser. So people that have this subwoofer at their event, they usually get a very good feedback from guests about the sound quality.
Okay, and what is this one?
Yeah, this is kind of what we were working on last half year. So it's a double 18-inch subwoofer, and it's made to be compact. In Europe here, everything's kind of tailored to a pallet size. So it's good to be loaded in a truck. It has wheels, so you can even move it by yourself as a single person. And the way it's designed is that it can be tuned for different sound preferences. So some people like a warm bass, some people like a very tight bass.
So what is a warm bass? What is a tight bass?
Imagine you listen to a subwoofer and you have the feeling that the bass hugs you. It's warm, it's pleasant, it's nice to listen to. But for other audiences, imagine hard tech, free tech, high BPM music, you want a really tight bass response. You want to feel the kick. You want to feel the impulse of the music. This is both possible, this design. So we use different drivers, different EQs, different filters to kind of tune the sound in one or other direction. But this is one good thing about this design, because otherwise, if you have a subwoofer, usually it sounds the way it sounds. And you like it or you don't. It fits your music or it doesn't. And it fits the venue or it doesn't.
And so with this subwoofer, you can change the drivers, and it can change like the pros and the drawbacks, the pros and the cons of your subwoofer. So you can have more impact, but maybe less extension, stuff like that. Is it like, that's an interesting topic. When you are designing a subwoofer, are you always having pros and cons? Are you always going into a direction or another?
So I think I made the mistakes when I started going into sound, that I thought there is the best speaker possible. There is this one speaker that reproduces sound in the best way and everyone likes it. And of course I was wrong. And like some time ago I discovered that every person has a different preference. So if you ask 10 people what their favorite sound system is or what their favorite speaker brand is, you will get 9 answers. And so when we get asked to outfit venues, for example, or people ask them to do sound for them, we always ask them, hey, what's your favorite sound system? Why do you like your favorite sound system? What's your preference in music? And then we can kind of advise them or show them different subwoofers. So if people are like, oh yeah, we want like really boomy, really loud music, we would recommend the Paraflex Elf. If they're like, yeah, we also have live music, we have a broad range of music styles we play, we would kind of recommend them this. If they have a smaller studio, these subwoofers are obviously too big. And for this audience, or for like listening bars, for example, we try to make smaller subwoofers, also smaller tops to go with, also different design language, because then it becomes more important. Here we have the HQS Cram 12. It's a double 12-inch design, which is very popular and very pleasant to listen to. It's compact, so you can move it yourself. So we're trying to have a design for every need, for every situation.
Okay. And what's the top?
This is a Solana top. It was developed by John White, and he published the plans. And the good thing about it is...
is it JW Sound?
Yes,
on
JW
Instagram?
Sound on Instagram.
Okay, this has become very, very popular, right?
Yes.
This kind of design. What does it come from?
So this is a kind of a mixture of being a multiple entry horn and a very smart way of designing a waveguide. So the waveguide is this kind of gray part here, and you see it has lots of weird-looking design kinks, and they kind of make it radiate the sound in a very equal way. And if you listen to these, you will see if you're standing right in front of them or left or right of them, they will always sound kind of homogenic and always the same way, which other designs don't.
Okay, so you got really super homogeneous directivity.
Yeah.
And what drivers are inside? How many?
Yeah, so the interesting part of these is because it's also a multiple entry horn, you have one high frequency driver, one compression driver in the center, and then you have 4 6-inch drivers doing the mids. And by kind of mounting them or like aligning them the way he did, or it is common in multiple entry horns, you get a very specific, nice sounding sound response.
Okay, and does it go low?
It depends. So you see...
for a speaker of this size, can we say it goes low?
Usually, of course, it doesn't. You see, it's a bass reflex design. So the bass reflex tuning defines how low it can play. The lowest recommended tuning from John White is about 50 hertz. And we are kind of tuning this to 70 hertz. So you get a reasonable output to, I would say, 80 hertz with this design.
So quite easy to match with any subwoofer, really.
Yes.
You don't have to have a super high subwoofer frequency.
So the thing is, it depends on how you prefer your music. In this case, if you like a lot of kick, the 4 6-inch drivers might not be what you're looking for. In this case, what we do, depending if the customer lets us know, hey, I want more kick, we use the HQS the subwoofer, and let it do the crossover a bit higher, because this design can play up to 160 hertz easily. So for example, if we have people that would like to have a dominant kick, we would cross over like 110, 120 hertz, and we sacrifice some details and in the kind of benefit of having more kick response.
Okay, great.
This design here is a Paraflex C3D double 12-inch. It's also designed by the HQS community, and it's becoming more and more popular.
And so it's a top speaker.
It's a top speaker, so it means it plays between, I would say, 80 hertz and 20 kilohertz. And the way it sounds like is very pleasant to people. So it has a very direct kick. Imagine you have 4 of them, and you can kind of play for an audience up to, I would say, 1,200 people easily. The benefit is also you can see the shape. It has a trapezoid shape. That means you can array them in a good way. So you put 2 of them together to have a very homogenic, like sound radiation from each side. So 2 of them per side gives you like a very universal kind of way of playing sound for an audience.
Okay, can you tell us more? Like what's inside? You are two drivers? No,
yeah.
Two kick drivers. Right.
Yeah, so inside, I hope you can see it, there's 2 12-inch drivers, and you have, of course, a couple of choices. So depending on what your preference in sound is, you can pick, of course, drivers you can buy from any big brands, but you can also buy the HQS drivers, which the design is currently optimized for. And inside you also see this waveguide here with 2 compression drivers attached.
And besides, are these face plugs that we see?
So this is a so-called duckbill.
Okay.
And what it does is it kind of evens out the frequency and phase response of the design. And this comes along with a cone plug, meaning another plastic part that fills the gap between the driver's membrane and the front of this. I can also show you later on how it looks like in detail. And this enables, when the design first came out, it didn't have these add-ons. And what happened was there was kind of, I think, a phase issue around 600 hertz. So ideally, you would have to cross it over to the, highs and compression driver around 600 hertz. So the only choice you had was using coaxial drivers. For example, like the DCX or BMS drivers, and they're very expensive. And to kind of make it more usable for the community, someone came up with these duckbills. This kind of makes it possible to cross over between the mids and the highs at around 900 or 2000 hertz, which is then a common crossover frequency for any type of compression driver.
And so you talked about the vents on the sides. So those are like a bass reflex thing?
So yeah, this is a quarter wave design. So it means it's a quarter wave resonator that works a bit different than a bass reflex design, for example. And what you can see here, you have this horn-like shape in the center, which is called the high-tuned resonator. That kind of enables the drivers to be kind of loaded in a way at the higher frequencies, the higher cutoff frequency. And this tunnel here that goes to the back of the driver is also a bit longer. That is a so-called low-tuned resonator that kind of, I would say, or simplified, amplifies the lower frequencies of the cabinet. And the response is kind of in a bandpass way. That means like everything that the cabinet is not tuned for is not played by the drivers. So even with an active crossover, the drivers wouldn't play a lot of frequencies below the tuned passband, which is currently, I think, 80 hertz. So if you measure this without a crossover, under 80 hertz, you wouldn't see much of a frequency response.
Can we talk about a bit all this quarter wave principle? Has it become popular in the last few years in sound system designing? Because I don't know much about the physics behind sound systems, but I see that a lot of people are getting into this principle. What is it? What are the benefits? What is the relation to Paraflex, QS, can you explain that?
Yeah, so the thing is, like, I don't know much about the physics, but I will tell you about what I know.
Okay.
I think how it worked out is it was a group of enthusiasts that kind of started designing speaker designs around this quarter with resonators. And the way it works is that within a certain passband, so the frequencies the cabinet is designed for, you have a lot of output for not much input. And the good thing about the project is it was kind of open from the beginning. So it's a community of people, a community of audio enthusiasts that co-develop these designs. So there's lots of stuff online. You find them on Facebook. It's a huge group. You can ask questions and you can discuss new designs. Meaning, when these designs came out, they looked a bit different. So people tested them and they said, hey, why don't we modify it a bit to play lower? Or they said, hey, why don't we add these phase plugs to make them play higher? This is the magic for me when it comes to this HQS group, because you have an idea, you pitch it, you get immediate feedback, you can ask any question you want, and you're not alone in developing speakers. So you have an idea and that might not work out, and you can ask people, hey, why did my idea fail, or why doesn't it work? And someone will help you with it. And this is the magic for me about this group, because you cannot ask stupid questions. You always get a good answer, and no one's making fun of you when you're not experienced at all. You're asking beginners questions.
Okay. So can we talk about the tops?
Yes. So when we look at the tops, you see here we have a 10-inch driver, and we have a coaxial compression driver here in a very specifically shaped horn. So yeah.
So it's a coaxial driver, you said?
Yes, it's a coaxial driver. That means it's one driver, but it has two membranes, one for high frequencies and one for low frequencies. And the benefit is that if you have an optimized membrane for higher frequencies, it sounds better, of course, than when you have a universal membrane that plays all frequencies. So the idea is that by kind of carefully aligning these membranes, or the way these membranes make sound, you cover a wide range of frequencies, from low to from mids to highs. But due to having specialized membranes or parts of the driver for it, it sounds way better than having only one driver or one membrane.
Okay. And so that's horn loaded?
Yes.
With a 3D printed horn?
With a 3D printed horn, yes.
Okay.
And so at some point we were looking at speaker designs, or at like designs that don't need bigger tops, like for example this one. We came about the Leclerc horn profile. And when you look at horns, or the history of horns, sometimes there's always pros and cons about a horn. So it loads, it means like you put less or little electric energy in it, and you get a lot of sound. But in return, if the horn's not matching the drivers, or if the horn design is not well made, you have certain effects like a beaming. Beaming means if you're directly in the front of the horn, it kind of shoots you with high frequencies, and if you go a bit to the side, you have not enough or little high frequencies, for example.
Okay, so it's quite easy to make a bad horn.
I guess it's quite easy to make a bad horn.
But nowadays, it's also a bit easier than before to do a good horn, isn't it?
I guess, but I think the technical knowledge you need is still quite high. So we benefited from this so-called Leclerc profile. And the guy who invented it, he made Excel sheets. So even people with no physical knowledge could kind of use his Excel sheets to make working horns. And what's the magic about this horn? You see, it has like a lot of curves. And the idea, as far as I understand it, is that by having these round shapes, the coupling between the horn, the energy coming out of the horn, the sound waves coming out of the horn, and the room is very harmonic. What I like about the sound of this horn is that the way it sounds is very airy and very pleasant. So it's not kind of throwing frequencies in your face. It's a very pleasant, airy way to listen to it, if that makes sense.
Okay, it does.
Yeah.
It does.
And when we started working with these designs or with these horns, maybe we can go to the other side. You see here we experimented with different shapes. So, for example, we saw the very popular Iwata horn shapes that are currently published a lot. And we wanted to see how they sound like. And we 3D printed one, or had a friend from Aachen print one for us. And we listened to it and we didn't like the sound because it wasn't what we were looking for. And also we believed we could do better. And then we used the Leclerc profile calculator we found online and started with these designs. And you see here they're split into this throat part and the mouth part. So we tried different throat designs and different mouth designs to see what we prefer, what we like. And at some point we found something that we found really pleasant to listen to. And then the next step was to kind of optimize the shape. Because every time you look at your speaker and you listen to music, I think it adds to the whole experience when you look at something you like. And then Manu came up with the idea to kind of optimize the shape. And after, I think, a year of experimenting and working on it, we ended up getting this. This is the latest prototype. It's not the final version yet. But for us, this is a good combination out of a very aesthetic-looking piece and a very satisfying sound experience.
And what's about those two horns, the highs horns?
Yeah. So
why are they different but looks the same?
Same but different, yes. So you see here, this is the original piece. This is a WG6, a waveguide 6 from HQS. And this is a mouthpiece made out of wood that has the same shape like this waveguide. And why are we remaking a piece that already works? We found out that when it comes to visual perception of sound, lots of people like wood. So we have lots of guests coming to us when we do sounded events, and they're like, oh yeah, we really like this aesthetics. And here in this design, you see, when you look at it, the black centerpiece is very obvious, and that's why we kind of experimenting now to see how people react to this.
So it's for the looks?
It's for the looks. And maybe in a second step, we can also kind of experiment with different geometries to kind of influence the radiation angle of the highs a bit.
Okay, I see.
Because sometimes people like these very direct highs, but sometimes people prefer a more, I don't know, playful highs, less direct, more indirect. I don't know how to describe it. And we try to achieve it by modifying this a bit.
Okay, I see.
And yeah, you can see here, you see different layers here. And how we make it, you see all these cabinets are made out of plywood, means like wood that is made of lots of layers, so it doesn't warp. And what we did is we just glued a lot of these wood pieces, these sheets together, and then we used the CNC to kind of carve out this shape. And we didn't only do it here. We're also working on this version here,
wow.
Which is not, hopefully maybe it premieres this Sunday. And you see here it's the same shape like the Solana horn, just made out of lots of layers of wood. And with the CNC machine, it takes us currently 8 hours to manufacture one of these pieces. And we want to see how people react to it. So obviously, because it's the same shape, it will sound the same, hopefully. It's a different material, but that doesn't make a big of a difference. But we want to give people a choice. If they want to have this clean gray look later on, or if they prefer a piece that they obviously see is made out of wood.
Can you show us the CNC?
Yes, let's go to the CNC. Yeah, so this is where most of our wooden pieces kind of are created. So we have a 3-axis CNC here at Motion Lab that we use to carve wood or cut wood pieces that we later on glue together to make cabinets. Yeah, I think we spend about 8-10 hours every week here making pieces, working on prototypes, trying out new things, and yeah.
So, what is a CNC for those who don't know? It's an automated wood work tool?
Yeah, so The CNC is kind of what we use when we create new speakers. We create them on the computer. So we have 3D models, and this machine carves out the parts for us. So we don't have to manually do cuts. And this machine kind of does everything in a very precise way. And it's also most of the time faster than doing it by hand.
And you can do some really weird shapes that would be quite tough to make on...
Yeah, that's correct. So you've seen the horns earlier, and imagine kind of carving them out by hand. You have to be a very skilled carpenter. You have to be very skilled with your tools. And it probably will take a day or two. And if you have to build multiple of them, it would take you weeks to finish. And this machine does it kind of automatically. So you kind of set it up in a way, and then it does its thing for 8 hours, and hopefully a good piece comes out, and maybe, or like lots of times it doesn't work, and then you kind of have to try again.
Okay, great. Can we see another workshop that is important?
Yes,
here?
let's do it. So yeah, this is MotionLab's wood workshop. And this is where we usually assemble speakers. And you can see there's tons of wood in here that's not ours. And that's a good thing about MotionLab. It's a shared workshop. So you're never alone. You always have company. And lots of times the people working with you have ideas how you can improve your work. So when I glued my speakers, there were people here and said, oh yeah, why don't you do it like this? Then it's easier for you, or it's quicker to assemble. Or I could also help people with their work and be like, hey, if you use the CNC and you do it in a different way, then you have less work afterwards assembling your pieces.
Okay. Can we see the metal workshop?
Yes, let's go there. Yes, so this is MotionLab's metal workshop. And why are we in here? Because when it comes to manufacturing prototypes, metalwork is a big part of it. So imagine you're making something that has to be ultralight. Of course, you use aluminum as a workpiece. For us, when it comes to speaker manufacturing, we are trying out new materials. So what we do is, for example, the waveguide you've seen in black plastic, you've seen it in wood. And the next stage is that we're trying waveguides made out of metal, for example.
Why do you want to use metal for
Yes, why do we want to use metal for waveguides? There's a couple of reasons for doing that. One is like, depending on how you do it, it sounds different, or it can sound in a different way. But the main reason currently for us is that it's aesthetic. So we have lots of people that really appreciate having, for example, metal or wooden pieces instead of plastic. And imagine you have a speaker design, and instead of black plastic, you have, for example, brass, shiny brass in front of you. And that's what we want to offer our customers, because we believe it's about choice. And when you're investing a lot of passion, time and money in your speaker, of course it should also please your design ideas. Yeah, so what we're trying to do is we are kind of tempted by the idea of making metal horns, for example. But using metal as a permanent piece of the cabinets we make, because we like the material, and here at MotionLab it's kind of easy to kind of manufacture these parts, and it's a nice challenge to have a new material to work with.
Okay, can't wait to see that.
Yes, so we also us as well. So we hope to have the first prototypes ready by the end of the year. And then usually we have listening sessions every month. So for people that are interested to see if metal really sounds different than plastic, then yeah, you're welcome and open to come by.
Cool. Should we go back?
Yes, let's go back. So yeah, here you see lots of 3D printers. So we have resin-based ones that kind of make parts out of a resin that laser hardens. We have normal FDM printers here that make parts layer by layer by kind of melting a plastic string. And these machines are kind of very handy when it comes to making like physical parts out of 3D designs. So meaning you design a part, a new waveguide or part of the speaker in the computer, and you want to try it out. You kind of use the 3D file, put it in this machine, and let's say 10 hours later you have the part and you can try it out. You can measure it, you can listen to it.
What are you doing here? Are you doing the beautiful heart-shaped thing?
These are ecto bags It's a project for an artist that I am printing for them. And it's gonna be exhibited in London. It's supposed to be uterus outside of the body, so we can dissociate pregnancy with the human body, like grow babies outside.
Nice, it looks great. Thank you.
Yeah, so this is the magic about motion apps. So some people work on like high-end art and design pieces. We work on practical parts for speakers, and you can do basically whatever you like with the machinery and infrastructure you have here.
Okay. So what about you? What do you do at Restless Audio?
Okay.
So I'm in charge of the design part. Mainly understanding what people like about the speakers in an aesthetic way and how they interact with the speakers. And actually I started with the horns. So yeah, let's say this was my first baby.
Okay, so what did you do?
So I basically designed the shape of the horn. So it was a lot of iterations, and it's kind of the daughter of the Lecliche and the Ivata horn, let's say. So yeah, it was a lot of understanding of prototyping and seeing how it sounds, how it looks good, and combining both. Until we came to this one, that's actually the best result we had so far, and we're actually very happy with it. And now also decide like going around the combination of the speakers, which ones go to like together better, not only sound-wise but also in the looks, designing the supports, and also this one. It's the one we did last. It was at a few festivals, and actually it was super nice to see how people reacted to this design. They were super interested in the looks. Even people were touching them. So my job, let's say, it's creating this part of the speaker. I don't know how to say it.
Yeah, you're in charge of the look.
Yeah, I'm in charge of the look and see how people how to engage people, not only with the sound but with the looks as well.
And what are your inspiration when you are having a new speaker design like?
So I try to have like the design following the function of the speakers, let's say as a rule. And I try to make very simple but appealing designs, let's say, yeah.
Isn't it hard to make a speaker beautiful but still make it workable and buildable?
It's very hard, yes. I have to be honest. Especially because you need to leave surfaces free. It's also sometimes quite tricky to attach them so they're stable, they don't vibrate, so they don't interfere with the sound. But it's a very nice challenge, I have to say.
Okay, I've heard of the future challenge of making metal horn.
Yes, let's see. We're working on that. So yeah, it's quite a journey, I have to say, but so far so good. So let's see where we go from now.
Great. I'm super excited to see that.
Yeah, me too.
So what's this big driver you have?
What's this big driver? So this is a carbon cone HOQS 18-inch driver. And why do I speak about it is because this is kind of unique. So not many driver manufacturers use carbon cone membranes. And what makes it so special is it has a very specific sound. So it has a very powerful motor and a very tight response. So in this HOQS ELF design, there's a couple of recommended drivers you could use to make it sound good. But every driver sounds different. And to my ears, to my preference, using a carbon cone driver that is very tight delivers the best performance in this cabinet. And after we had this great combination here with the ELF and this carbon cone driver, we also decided to try it in our double 18-inch subwoofers. And this is a combination we recommend to people that really like tight techno music or like tight beats and less warm sound. That's why we were very happy to have a different choice of like components and also cabinets. So we use many big manufacturers. La Voce is one of our supporters. We like to work with the HOQS drivers because they have these like really specific and high-powered versions of common sizes like 18-inch or 21-inch.
And why do you like working with La Voce?
I like working with Lavoche because the story is this, that at some point we were advertising the second iteration of our yearly hackathon, Weekend of Sound. And we got in touch with Lavoche, and Kevin, the head of sales of Lavoche, he was like, "Oh, can I come and visit?" And we were like, "Oh wow, it's such a one of these important people is coming to our event." And we were a bit nervous about it because we were like, "Oh yeah, we're this enthusiast, we have these open source designs, and this professional person is coming to visit us." And he came, and it was super lovely because he loves to connect to the community. He loves to kind of support open source projects and people that develop speakers and people that share knowledge within the audio community.
Okay. And what is Weekend of Sound?
Weekend of Sound is our yearly hackathon. So when we started with sound, we learned a lot from other people. So I spent a lot of time in online forums, also visiting other people, or I spoke to people that had their own self-made sound systems, and that kind of got me the right ideas where to start. And the idea with Weekend of Sound is to give back, to give the community an event where they can exchange ideas, where they can learn new stuff. We have lots of workshops, we have tons of designs. We have also some of the designers from these projects coming here to Berlin. And so you have the opportunity to kind of find out what's your favorite design, but also learn about how it works, or maybe also how to get the knowledge to create your own speaker designs.
Okay, great. And you said every month we can have a listen here?
Yes, so every time we can afford it time-wise, we're trying to have a monthly listening session here at Motion Lab in Berlin. So if you're interested in here listening to any of our designs or any of the designs we kind of prototype, contact us because we try to kind of do it once a month, so people can come and also exchange ideas, ask questions, because sometimes you heard about a design, but you don't know if it's the right thing for you, and we try to kind of support people as good as possible.